This is the second lesson that falls within the section 1.5 in college algebra, and we're going to continue to solve quadratic equations, but this is a technique used for a very specialized form of a quadratic equation. Now, I'm going to start this video lecture with something a little bit extra that you could do this lesson just fine without, but I feel like I need to explain not only how to use what's called the square root property, but to show you beforehand why it works. Now, once again, you're not going to use this particular information within the context of each one of these problems, but this is why the square root property works. All right, the square root property is a property we use when we have a variable squared equal to a constant number, and I'm just going to pick a number 7. All right, to do this, I won't use this language as I work through each of the problems, but I'm going to do it just prior to the lesson. To do this, you always do the inverse of whatever is done to your variable. If it's x plus 2, you subtract 2. If it's 5 times x, you divide by 5. Well, if it's x squared, the inverse operation is square root. So I'm going to take the square root of x squared equals the square root of 7. Now, I'm going to introduce right now something that I won't talk about as I do each problem, but there is a definition in mathematics. Definition means you don't prove it, you have to accept it. That says the square root of x squared is equal to the absolute value of x. But in order to say that the absolute value of x is the square root of 7, x will equal either the positive square root of 7, because the absolute value of the square root of 7 is the square root of 7, or the negative square root of 7, because the absolute value of the negative square root of 7 is also positive 7. Let me give you another example. Suppose I had x squared is equal to 4, and I take the square root of the left side and I take the square root of the right side, and I get the absolute value of x is equal to, and the square root of 4 is 2. I couldn't simplify this one, but I could simplify this one. Absolute value. Absolute value of a quantity means take the sign off. So if x is 2, the absolute value of 2, we'll just put it over here, is 2. But if x is negative 2, the absolute value of negative 2 is also 2. It is because of this definition that we will always get two answers using the square root property. So what I will write will be a little different because I'm not going to show this every time. What I'm going to do is when I take the square root of x squared, I'm just going to write x, and then I'm going to put x is equal to, I'm going to put plus or minus the square root of 7. I'm going to use this symbol to say when you take the square root, both the positive and the negative square roots is what you need. Over here, I could say x is plus or minus 2. All right, so let's go ahead and take a look. Let me say one more thing before we get started. When we did factoring as a technique, let me get a little room and write this down for you. Oops. When we used factoring as a technique for solving quadratic equations, we had to have ax squared plus bx plus c equals 0, and we had that little rule, a couldn't be 0. When we use the square root property, we're going to need our variable squared equal some kind of constant, or something involving our variable squared equal a constant. But the format must be a square on the left-hand side, whether it's a monomial squared or a binomial squared, and it's equal to a constant. All right, so our first problem to solve is not in the right format, but we can get it in the right format. We have 2x squared plus 9 is equal to 29. I need the x squared term isolated by itself. So I'm going to subtract 9 from both sides. That gives me 2x squared is equal to 20. It's not isolated yet. I'm going to divide by 2, and I get x squared is 10. Now it's ready for the square root property. The square root of x squared is x. We will take both the positive and the negative square roots of 10. We will always pause right there to see and ask if we can simplify. The answer is we cannot simplify this radical, so those are your answers. Now you'll need to check in my math lab. It could be that you need to separate this into negative square root of 10, comma, square root of 10. That is both the positive and the negative. You can check under the tools, and if the plus or minus symbol is available, you can select it and then do square root of 10. This is like a compound version of these two answers. All right, let's look at number 2. All right. For number 2, I check to see it tells me to use the square root property. Is it in the correct format? Is it something squared equals a constant? The answer is yes. So I have parentheses, x minus 5 quantity squared is equal to 81. Using the square root property, I take the square root of the left side, which drops off the square, and I have to remember to take both the positive and the negative square roots of 81. This is something that you're going to have to remember. It comes from that definition that I discussed. Can this be simplified? Yes. So x minus 5 is equal to 81 is a perfect square, so this is plus or minus 9. X, we need to solve for x, so I'm going to add 5, and when I add 5 to the right hand side, please put it in front of the plus or minus symbol. I see way too many mistakes if it is put behind. So I have x is equal to 5 plus or minus 9. Well, I can get two answers. X is equal to 5 plus 9, which is 14, or x is equal to 5 minus 9, which is negative 4. My math lab will not accept this as an answer because it can be simplified into these two. So this time I have no choice. I need to put the two answers separated by a comma. Let's look at number 3. It says to use the square root property. Something squared equals a constant, but this 5 does not need to be over on the squared side. So I will need to isolate. So I have 5 parentheses x plus 1 quantity squared equals 60. Divide by 5, divide by 5, and I have x plus 1 quantity squared is equal to 12. So now I do have something squared equals a constant. Using the square root property, I will take the square root of this, so I just get x plus 1 equals, you have to remember it's plus or minus the square roots of 12. Question, can you simplify? And the answer is yes. X plus 1 equals plus or minus, let's see, the square root of 12 is the square root of 4 times the square root of 3, because that's a perfect square factor, so that's 2 times the square root of 3. We did our unit on radicals, and simplifying was important. Now I need to finish solving for x. Subtract 1, put it in front. X is equal to negative 1 plus or minus 2 times the square root of 3. Now this time you can leave it as a compound answer, provided you can find this symbol in my math lab. They have changed some things in my math lab, and it has shown up on some problems and maybe not on some other problems. But these are not like terms and cannot be combined because of the radical, whereas in our previous problem, these were both rational values that could be added and subtracted. So you can either write your answer as a combined form, or negative 1 plus 2 times the square root of 3, comma, negative 1 minus 2 square root of 3. So it's got to be in one of these two formats. Let's look at number 4. Square root property. I have something squared is equal to a number. So it's ready, and I'll copy down the problem. Square root property says take the square root, which gets rid of your exponent, put the plus or minus square root of negative 49. Don't forget this, because you'll just get one answer, and there are two. Remember, you always ask, can you simplify? Well, the square root of negative 49, the negative means there's an I. The square root of 49 is 7, so this is 7i. So x plus 8 is equal to, keeping the plus or minus symbol, 7i. I need to subtract 8 from both sides, and I have x is equal to negative 8 plus or minus 7i. That is an acceptable compound form, or negative 8 plus 7i, comma, negative 8 minus 7i. Now, I don't know that you would have noticed this, but look at these two answers. Do you remember from previous math that these are conjugates? Imaginary or complex answers always come in conjugate pairs. Moving on to number 5. Use the square root property. Something squared is equal to negative 7. So yes, it is in the right format. I'll copy the problem down. X minus 3 squared is equal to negative 7. Using the square root property, that becomes x minus 3 is equal to plus or minus the square root of negative 7. You are taking the square root of both sides. On the left side, it just gets rid of the square. On the right, it shows up as a radical. Don't forget your plus or minus. Can you simplify this? Well, the square root of negative 7 is I times the square root of positive 7, and that's all you can do with that. So I have x minus 3 is equal to plus or minus I square root of 7. I need to add 3 to both sides. Remember to put it in front. X is equal to 3 plus or minus I times the square root of 7. If you expanded it to the two answers, it's 3 plus I square root of 7. Make sure you get out of the radical for the comma, and then 3 minus I square root of 7. Either the compound answer or the two answers. Let's move on to number 6. Sorry about the sniffle. Square root property is required. It's a quantity squared equal a constant, so I can use it without any changes. Open parentheses, 5x plus 6, quantity squared is equal to 4. Using the square root property, I have 5x plus 6 is equal to plus or minus the square root of 4. Can you simplify that? Yes, that's plus or minus rational 2. So 5x plus 6 is equal to 2. Now I need to continue. I'm going to subtract 6 from both sides, put it in front. So I have 5x is equal to negative 6 plus or minus 2. Divide by 5. And I have x is equal to negative 6 plus or minus 2 over 5. You cannot leave this combined answer because it can be simplified. So let's take a minute over here and do it. One of my answers is negative 6 plus 2 over 5, which is negative 4 over 5, and that's an answer. The other answer is negative 6 minus 2 over 5, which is negative 8 over 5. If either of those could be reduced, then I would need to do so, but that's not the case, so I have negative 4/5. Make sure you get out of the denominator to put your comma, negative 8/5. All right, number 7. I do have a quantity squared equal a constant number. That means that I can use the square root property. So parentheses, 2x plus minus 3 squared is equal to 23. Square root property says that I have 2x minus 3 is equal to plus or minus the square root of 23. This time when I ask if I can simplify, the answer is no. So I will just leave this and move on to the next step. I will add 3 to both sides. So I have 2x is equal to 3 plus or minus the square root of 23. Divide by 2, and x is equal to, in a combined form, it is 3 plus or minus the square root of 23 over 2. In a list form, it is 3 plus the square root of 23 all over 2. Make sure you get out of that denominator to put your comma. 3 minus the square root of 23 over 2. And I think that the next one is our final problem. All of these have been square root property. You only use it when it's appropriate, meaning that you on one side you have a quantity squared and it's equal to a constant. So I have parentheses 4x minus 4, quantity squared is equal to 18. Square root property says take the square root of the left side equals plus or minus the square root of 18. And I always want to know if that can be simplified, so I'll go over here. The square root of 18 is the square root of 9 times the square root of 2, which is 3 times the square root of 2. So I have 4x minus 4 is equal to plus or minus 3 times the square root of 2. Add 4 to both sides. Remember, we're always putting it in front. So I have 4x is equal to 4 plus or minus 3 times the square root of 2. Finally, I will divide by 4, and I have x is equal to 4 plus or minus 3 times the square root of 2 over 4. That's the answer in a combined form. If you separate it, you'll have 4 plus 3 times the square root of 2 over 4, comma, 4 minus 3 times the square root of 2 over 4. If you are tempted to do some reducing with those 4's, don't do it. The reason being 4 is not a factor of the entire numerator, so you cannot divide it out. You may write your answer in a combined form if you have access to this symbol, or separate it. So that is the square root property, and you will see how it's used in our next technique as well.